Hi, here's Professor Verkler again with ECE 1220 at the University of Utah, and today we're going to talk about current dividers. First, we'll learn how to identify current dividers, then we will learn how to calculate currents in a current divider, and finally we will design current dividers. So let's go back to the principles we learned last unit with KVL, KCL, and Ohm's law, and try to figure out how to relate currents for resistors in parallel. I will give you 5 seconds to try to solve this problem on your own, and then I will solve it. So please pause the video now. Okay, so using KCL, I know that 1 milliamp must be equal to I1 plus I2. That's one piece of information I know. The other piece of information I know looking at this is that these two resistors are in parallel. So if they are in parallel, they must have the same voltage. Now, using Ohm's law, if voltage is held constant, then that means if I increase resistance by 2, I must have to decrease current by 2 to hold voltage constant. So that means, notice, right, it's an inverse proportionality here. So that means that more resistance equals less current. So because both of these resistors have the same voltage across them, if this one has double the resistance, it must have half the current of the other. So which answer is that over here? It's that I2 is half of I1, or I1 is double I2 is equivalent to that. Okay, so now we'll learn formally about a current divider. So a current divider applies to resistors in parallel. Resistors split the current by the inverse ratio of their resistances. I know that sounds a little weird, but remember, smaller resistors do have more current, so it's like inversely proportional now to resistance. And so the fraction of the current is the fraction of the resistance of the other resistor. We're going to start with Ohm's law, V equals IR, and we're going to start with KCL. I total must be equal to I1 plus I2. And now we'll apply Ohm's law for each resistor. So V is equal to I1 times R1, and V is equal to I2 times R2. Notice that because they're in parallel, they share the same voltage. And so then I can set these two equal to each other to get I1 R1 is equal to I2 R2. And so I want to isolate a variable so I can stick it over in this equation and remove a variable. So I'm going to get I2 alone. I2 is equal to I1 times R1 all over R2. And I can plug that in for I2 over here. So I get I total is equal to I1 plus I1 R1 over R2. So now I'm going to pull out the I1. So I get 1 plus R1 over R2. And then I can multiply here by R2 over R2 to get I1 R2 plus R1 over R2, because now they have a common denominator of R2, and so I just added the numerators. And then the final step will just be to rearrange so that we get I1 is equal to So if I want to get I1 alone, I need to multiply by the reciprocal. So that becomes R2 over R2 plus R1 multiplied by I tote on the other side. So let's see how that equation relates to this down here. So notice to calculate for the current I1, I put the other resistor, R2, in the numerator. So that's why this is other. And then again, just like the voltage divider, R total will be each of the resistances added. Then I total is the total current coming into the branch off. And here I just labeled divider for whichever one you wanted. So that means if we wanted to get I2, we would do R1 over R1 plus R2 times I tote. Now please note this is a little different than the voltage divider equation. This doesn't just keep scaling as I add more resistors. Okay, let us do a worked example. So again, I like to label all the currents when I start. So 8 amps and the resistances, here's 1 kiloohm and here's 3 kiloohms. So then what are I1 and I2? So I1 is going to be the other resistance, so in this case 3 kiloohms, divided by the total resistance added, so 1 kiloohm plus 3 kiloohms, multiplied by the total current, which is 8 amps in this case. So now I have 3/4 of 8, which gives me 6 amps. Okay, now let us do I2. So in this case, we're going to look at the other resistor, which is R1. So we'll put 1 kiloohm in the numerator. And we still have the sum being 1 kiloohm plus 3 kiloohms in the numerator. And then we multiply by the total current, again, 8 amps. And notice that the units here are canceling each other in the numerator and the denominator. Okay, and so this time we end up with 1/4 times 8, which is equal to 2 amps. And again, we can double check our answer mathematically by making sure that KCL holds. So 6 amps plus 2 amps gives 8 amps. And then finally, I would like us to do a design problem. So choose R1 and R2 such that I1 is 4 times greater than I2. So using the principle of a current divider, because the two resistors are in parallel, I can say that the resistor 4 times greater in resistance has 1/4 the current, and that is due to the inverse proportionality in Ohm's law of I and R. And that is the principle upon which a voltage divider is created. So in this case, I am looking for I1 to be 4 times greater than I2. So that means that I2 has less current, so it should be the greater resistance. So it's going to be 4R, and this is going to be R. So again, like in the voltage divider lecture, This is an under-constrained problem. So that means that there are infinitely many answers, and as long as we make this ratio hold true, our answer should work, and you just pick one answer. So again, picking a kind of standard value from our lab kits, maybe I'll pick that R1, which is R, is equal to 1 kiloohm. So that means that R2 needs to be 4R and should be 4 kiloohms. Let us check that that answer works. So in this case, right, they gave us a voltage here, so I could just apply Ohm's law to each. 9 volts divided by 1 kiloohm will give me I1, and I2 is 9 volts divided by 4 kiloohms. So right here, I get 9 milliamps. And right here, I get 9/4 milliamps. And if I multiply this by 4, I get 9 milliamps. So you can see that I2 is 4 times less than I1, which is the same thing as saying I1 is 4 times greater than I2. Oops, I'm in the way again. Sorry. And again, there are multiple correct answers. I could have done twice each of those values, 2 kiloohms and 8 kiloohms. I could have done half of those values, so 500 ohms and 2 kiloohms for my two resistors. Anything I multiply, any ratio, as long as I keep the ratio the same, anything I multiply both those numbers by is a correct answer. And with that, I think you are ready to do the worksheet and homework.